Hello. I'm afraid this is take 3 or 4 because this particular episode isn't going well. So I've made a couple of changes, and I instead of reverting, I'm just going to show them to you. So the big change I made that you need to be aware of is that I changed these values to be more in tune with what they actually are on the image rather than trying to adapt to some kind of bump map. And then I just make it so that the bricks are arrayed horizontally across, so brick 1 is at the far left and brick 4 is at the far right. The other thing I'm doing is I'm just kind of farting around with this mountain value stuff. I'm just trying to get the mountain value to look right, so I want to have a very smooth landscape that has the right look to it before I start to add in the noise, which will determine the smaller grain details. So you can see that this is what it will normally look like without any kind of height manipulation. And that means that we have these very smooth curves, but since there's no height-based weighting, they kind of just float randomly in the sky. So what we need to do is we need to bring that down so that it works. Let's delete these. So that it works at a specific height and everything is weighted more properly. So what we're going to do is we're going to go ahead and say float height base equals 10, and that's just going to be, it should never go, if it's below 10 it should always be solid according to the mountains, although obviously the noise value later will manipulate that. So mountain value calculate noise blah 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 blah, and then we want to make it so that mountain value will be weighted down so that 0 counts at y equals height base and below, but above that it gets significantly less popular. So the first thing we're going to do is going to create a float height above base, and that would equal y minus height base. So if y is equal to 0, then this height above base would be equal to -10, whereas if y is equal to 20, this would be equal to 10. So all we really want to do is subtract some multiple of height above base from mountain value. Something like that. That might be something like that. Let's go ahead and see whether that works. Looks good. So here we're encountering an issue where the mountains are not very severe. They're very, 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 very gentle, and they're too gentle. And there's a lot of reasons for that and a lot of ways that we're going to want to change that. But for now, let's go ahead and change that mountain value so that it actually represents a specific y cutoff rather than just being arbitrarily multiplied by us. So for that, what we're going to need is we're going to need a max height. So we'll leave 10 blocks above our highest peak for random stuff, and then we're also going to need a height swing. So here when we do our mountain value stuff, we actually don't give a shit about that. What we want to do is we want to say mountain value times equals height swing. And that will give us a maximum, that'll give us the exact y value. Below this mountain value, it doesn't show up, and above that, below it does show up, and above it doesn't. But that's the height swing, so we also need to add in our height base, like that. And then down here, we're going to say if mountain value is greater than or equal to y, then that works. We like that. Good. So that should give us mountains. Oh, see, I knew this was going to happen. I screwed up somehow. Mountain value plus equals height base. If mountain value, so I'm debugging at this point. Let's just go ahead and see what sort of errors are being caused by that particular array. Failed at minimum height. So you can see that we actually have mountain values of less than 1, which makes no sense. So height swing is equal to 20, I believe. Might as well debug it. But it's equal to a fairly large integer, so mountain value times height swing should give us a number between 0 and 20. And then we add in height base, which is equal to 10, which should give us a number between 10 and 30. So then when we say if mountain value is greater than y, when y equals 10, it should always be greater than or equal to y. How in the world would mountain value ever end up with a 0 point something? There's another thing we can check. What? The noise value is giving us negative values? I didn't know it could do that. I thought it was between 0 and 1. Let's check the documentation. Well, regardless of whatever I was thinking, it apparently does in fact create negative numbers. So here in calculate noise, we're actually going to cap this. So that it will never return a negative value. I sure hope that 1 is the maximum value and it's not like something weird where it'll return 70 or it'll only return 0.6. But it looks like that height is proper, so I guess 1 is probably the maximum value. So the thousands of takes that I told, the 4 takes, this is the 4th take, I figured it out. Finally, the reason I was so bad at math is because it's returning negative values and I didn't expect it to. So here you can see that we have something vaguely resembling a very basic height system. If you wanted to have a more severe height system, you can actually square the mountain value before you do any of this stuff. And we don't need this anymore. Alright, let's just go ahead and check and make sure that we didn't have any of those. Yeah, now that it's no longer returning negative values, it works. I pressed that twice. Oh, there we go. So when we square it, it means that it's much, much more likely to be 0, or very, very close to 0. But on the other hand, when it starts to go up, it will have these spikes, and you'll have these much sharper, so you have like flatlands with rather high mountains like this. Another thing you can do is you can do ease in out, where you'll get gentle hills and then suddenly it'll spike, and then the tips won't be this rounded tip that we have here, but instead will be much, much more severe peaks. And we could actually do that we can try square rooting it as well. So you can play around with this to figure out what kind of height, what kind of visual you want. Do you want to have gently sloping hills? Do you want to have mountains? Do you want to have, well, what do you want? How sharp do you want your mountains to be? Do you want the tops to be this gentle rounded slope, or do you want to have a spike there? And just to show you what I mean, when we do this mountain value times mountain value, let's change that out with a mountain value equals mathf.square root mountain value, which is the opposite. And you can see that in this case, we have this really, really weird situation where the mountains actually are tending towards the top rather than tending towards the bottom, and that's because I square rooted it, which means that values between 0 and 1 that get square rooted are much closer to 1 than to 0, whereas if you square them, they're much closer to 0 than to 1. But the end result is that we've got these floating mountains. They're not actually floating as a thing. Actually, they're not floating. They're just popping up. They are much more like, I don't know if you've ever been to Grand Canyons or the Painted Hills, but they're much more like something where a river came through and eroded away underneath, and you're left with these particular kinds of situations. Now, you may think to yourself, oh, this is really unrealistic. Well, it's okay. There's a lot of things you can do with this, and you don't have to say that that's unrealistic because it's so smooth, because we can add arbitrary values. So for example, let's just go ahead and say mountain value plus equals, let's take this grain 0 offset and use it. So this is a value between 0 and 1, which only gives us one height width. So we actually want to make this a value between 0 and 10, but we also want to subtract 5. So that will change our value by 5 up or 5 down. And you can see that it no longer looks quite so basic. We now have some pretty sharp variation going on here. And we can get much, much sharper variation if we would like. Now, later on, you're going to want to add in functions that check for this sort of crap. And generally speaking, you just fill in beneath it. You don't worry too much about trying to cull it. You just do a quick little fill in, and that's good enough. But you can see that now we've got all sorts of interesting terrain happening, and this is what I was trying to do for the past hour. But I kept screwing up because apparently our noise generator returns the negative values, and I didn't know that. My draw distance is really low, in case you're wondering. The other thing I wanted to do was I wanted to make these bricks different, but that's going to wait. I put in the code needed to make the bricks differ, but I'm going to wait on that so that we don't have to spend a lot more time on this particular episode. It's taken long enough as it is. Oh, I'm not 100% sure, but just in case you're wondering, I think I covered this in an episode that you actually saw, like the last episode, but just to be very, very clear, I deleted a line here.